This is Stick. Tonight, he's doing what everyone does at 1 a.m., watching a documentary about black holes and slightly panicking. Everyone knows the story. A black hole is a cosmic vacuum cleaner. It sucks in everything nearby. Light, planets, everything. So Stick has a very natural, very stupid question. What would happen if he swallowed a tiny one? Not a big one, just a little black hole, something pocket-sized. How bad could a tiny thing really be?
So what if he did? What if Stick actually swallowed a tiny black hole? Let's find out, honestly.
Here's the first surprise. There isn't one answer. It depends entirely on a single number, the black hole's mass.
A black hole isn't defined by size. It's defined by how much stuff is crushed into a point. Same rule, wildly different results.
A tiny black hole could weigh less than a feather, or as much as a mountain, or a moon. The word tiny is hiding a lot.
So let's do the only sensible thing. Turn the dial up one setting at a time and watch what happens to Stick.
Setting 1. Featherweight. A black hole with the mass of a few atoms, the tiniest thing we can imagine.
You'd think harmless, and you'd be almost right. Except a black hole this small does something strange. It evaporates. Black holes aren't actually forever. The small ones leak energy and shrink, and the smaller they get, the faster they go. A featherweight black hole would vanish in a puff before it even reached the stomach. Anticlimax. Next setting. Setting 2. Crank it up to about 1 kilogram, a bag of sugar squeezed to a point. Now it gets loud. That same evaporation now releases the energy of its entire mass, all at once. 1 kilogram becomes roughly 20 megatons, a large nuclear bomb.
The smaller a black hole is, the hotter it burns. A kilogram-sized one doesn't sit quietly in your gut. It detonates.
So Stick doesn't get sucked in. Stick and a good chunk of the neighborhood go up in a flash of light. Which is our first real lesson. With black holes, tiny does not mean gentle. Sometimes tiny means bomb. Let's slow down, because this is the part almost nobody expects. Black holes are not perfectly black. They glow. It's called Hawking radiation. Every black hole slowly leaks itself away as light and particles. The giant ones do it unimaginably slowly. But the smaller the black hole, the hotter it runs and the faster it leaks, until, at the very end, it goes off like a bomb. So the terrifying black hole isn't the giant one out in space. It's the little one in your hand. Funny how that works. Reassuringly, nobody has ever made one of these. We've never even seen a black hole this small. They might not exist at all. Setting 3. Crank the dial way up. The mass of a mountain, crushed into a point smaller than an atom. Now it's stable. A mountain mass black hole lives for billions of years. It won't evaporate anytime soon. So this time, Stick actually swallows it. And he feels almost nothing. Because here's the thing. This black hole is smaller than a single atom. It doesn't sit in his stomach like a marble. There's nothing to sit on. It's a speck of pure gravity, and it starts to fall. Straight down, through his stomach, through the couch, through the floor. Stick barely feels a pinprick. Why doesn't it shred him? An atom is mostly empty space. A mountain mass black hole is smaller than the nucleus at its center. It slips through the gaps. It's not a vacuum sweeping matter in. It's a needle so fine it passes between the bricks the whole world is made of. So swallowing it isn't the disaster. Swallowing it is almost boring. The disaster is where it goes next. Because it's still falling, and the only thing under Stick's floor is the entire planet Earth. The black hole falls into the Earth, and the Earth, from its point of view, is also mostly empty space.
It plunges to the center, overshoots, and comes out the other side, then falls back and forth through the whole planet.
Forever. A tiny knot of gravity, sloshing through the core like a pendulum that never quite stops.
And every single pass, it eats, just a little, an atom here, an atom there, very, very slowly.
Now, before you panic, a mountain mass black hole would take longer than the current age of the universe to eat the Earth.
You would never notice it in your lifetime, or your civilizations, or your species. It's a next eon problem, not a next week one.
So at this setting, Stick's terrible mistake is basically a very slow leak in the planet, billions of years from being anyone's problem.
Setting 4. Turn the dial to the mass of a large asteroid. Now, finally, gravity starts to bite. Now, it's heavy enough that as it passes through Stick, the gravity right next to it is savage. Anything within a hair of it gets stretched apart. Scientists have a word for it: spaghettification. The pull on your near side dwarfs the pull on your far side, and you're drawn into a thread. For Stick, that's a very bad day along one narrow line, and then the black hole drops into the Earth, heavier and hungrier than before. Setting 5. Let's stop being polite. Give it the mass of the moon, squeezed to the size of a grain of sand. Now, the mass alone is a catastrophe. A moon's worth of gravity suddenly loose inside the Earth. It sinks fast, it eats fast, and the tides it raises start pulling the planet apart. At this setting, there's no clever twist. Stick ended the world by swallowing something the size of a grain of sand. Same object, same tiny black hole. The only thing we changed was one number, and we went from a puff of smoke to a dead planet. So, what if you swallowed a tiny black hole? We ran the whole dial, and notice what actually happened. The featherweight did nothing. The kilogram was a nuclear bomb. The mountain was a slow leak. The moon ended everything. One question, 5 different worlds. Which makes the honest answer a little annoying. Tiny was doing a lot of work in that question. But there's a bigger myth hiding under all of this. The one from the documentary, that black holes suck everything in. They don't. Gravity only cares about 2 things: how much mass and how far away, not whether it happens to be a black hole. Here's the proof. Swap the sun for a black hole of the exact same mass, and Earth's orbit would not change at all. We'd freeze in the dark, obviously, but we would not get sucked in. We'd keep circling, exactly as before. Yes, black holes can devour whole stars, but only ones that wander too close. From a safe distance, they just orbit, like anything else. A black hole isn't a cosmic drain. It's just an object, a very heavy, very small object, mostly minding its own business. So what actually makes a black hole dangerous isn't suction. It's 2 things: get close or get small. Get close and the tides tear you into a thread. That's the spaghetti, but you have to get right up next to it first. Or make it tiny, and Hawking radiation turns it into a bomb. But a big black hole, far away, is one of the calmest things in the universe. The scary part was never the swallowing. It was the density up close, and the physics of the very, very small. So, could you actually ever swallow a tiny black hole? Honestly, no. And not for the reason you'd think. If it's light enough to be safe, it evaporates before it touches your lips. If it's heavy enough to survive, it falls straight through you. There's no version where it just sits in your stomach like a superpower. Gravity doesn't do souvenirs. The real answer depended entirely on one number you were never given, and that number changed absolutely everything. Black holes aren't monsters that hunt you across the galaxy. They're just mass and distance, playing by the same rules as everything else. The scariest thing about the question was never the black hole. It was the word tiny, quietly hiding a moon. Turns out the universe answers your questions exactly as literally as you ask them, so maybe ask better ones.
Stick survived 4 settings out of 5, mostly by luck and by physics being a lot weirder than the movies.
The vacuum cleaner in the sky was never coming for you. It was busy being a rock. A very, very heavy rock.
Stick life. Next time, what if you were the last person left on Earth?